Okay, this is all about the biology and the geology of mud fossils. This lung was DNA tested, and it's human, no question about it, and it is in absolutely pristine condition, and the blood that came out of here was raw red blood. Now, this one had all the pleura missing, and you could see the alveoli, which are these. I'm going to home in on this in a second. These little red dots had blood coming out of them. Not all of them, but a number of them. You see that? That's what came out of them. Now we're going to look at this in a microscope in a second, the one that had completely turned to silicon, that one right there. This is completely turned to silicon, except a little bit of red blood here and there inside the alveoli. Now we're going to look at that close. But where you see those red spots, that's where blood was. And that right down there at the bottom, what you're looking at there right now, that's where the spurlock is. Now I want to show you that in a microscope right now, live. This one here is in a picture on the screen. But here is that lung in the microscope. Now we're going to be looking at the spurlock over here. So get ready. I want to prove, I mean, I've shown it in every single lung has them. Well, every single body part has it wherever it attaches. And that's why it keeps the fluids that are in the membrane that would have surrounded this in a certain condition. And I don't know how it does it or how, but the only thing I can take away is there's so many different cancers because every bag is different. And that means everyone has different chemistry because they're dealing with different organs and different body tissues. So that's why you get this kind of cancer, that kind of cancer. There's over 100 cancers, more than that. And it's every one of them is invasion. Invasion of what? Invasion of the membrane. If you break it down to what every one of them has in common is invasion of the membrane. And then the tumor invades good fleshy tissue that you usually use to live, and it starts living on there, and it gets bigger and bigger, and it consumes you. That's what cancer, every invasive disease has to get through that membrane. Now this one doesn't even have a membrane on it. So we're going to look at what's underneath the membrane when you get down to where the alveoli, which is these things right here. All right, these are the alveoli, all these little spongy looking things. All right, and they are these things right here, these little circles. And we're going to be looking at them in the microscope. And I'm going to show you the spurlock here and see if we can see it. Does it have the same characteristics as the rest of them? I say it will. I've shown it on this. I've shown it on all of them. And this, at present, the spurlock is unknown to a medical science. And here it is right there. Here's a spurlock. There's a little flappy tag. And I say there'll be one right over there hanging off of this that would hold itself in position in the body so that it wouldn't go flapping around. That lung is this lung. And that's going to get held right here so that it doesn't go flying around in your body. Just like this one gets held right there so it doesn't go flying around. That's all it's all about. Here we go. We're going to be looking for the spurlock. All right, this is not easy to see, and this thing is extremely eroded, and it died flat on that side. See it? Heavily eroded. This side's just totally eroded. That you can see it died flat, like this side, and all the blood ran down to this bottom like that. Now, the spurlock is here. You may have a hard time seeing. I can see it very easily. But that little triangular spot right there, and the fluid's running out of there. Now let's look at it in a microscope and see if we can see the actual spots like I show on the other ones. And I believe I can see them right there. So let's take a look. While we're looking at this, remember I showed you that flat spot on that? They all have a flat spot where they died in the Great Flood. And the flat part that was laying in the mud is absolutely flawless. Although this one is flawless on both sides. And this one here, same thing, flat on one side. They all died in the Great Flood. And that's why the body parts are disassociated, and they had actually boiled out from the other parts of the body. And this has that fascia, the same fascia as we're looking there, only it's peeled off. Just some of it. A lot of it's still on there, but see how thick that is? That's how your lungs can do this all the time. It's like a big rubber bag. And then the guy died, and then it boiled out of the body. And this also has the spur lock on here too. They all have it. They all have it. So anyway, that's a new body part, and we're going to look at that in the microscope. All right, keep your eye on this. This is the spur lock. Now, I'm going to jiggle it around, so it's going to be all floppy here, but you can see this is at the end right there. It keeps coming down and stops right there at the end. It's very hard to focus when I'm moving it by hand, so bear with me. That's the very end of the spur lock. Now, it comes back from there into the lung. All right, you see it there? That's strappy stuff, really tough and strappy. It comes all the way back this way into the lung. And when it gets into the lung, you'll start seeing the alveoli. Alright, so now this is the really gnarly spot that locks it into the lung. Now if we keep going further, we're going to start seeing the alveoli. You see up in here? There's the alveoli. You come right down to the very bottom. Whoops. It's hard to get this oriented, but anyway, this right here is a spur lock. Oops. That's probably the best I'm going to be able to do. It comes down here and it locks right at the end. You see it? That's where it locks in solid. And I believe that's where the fluids transfer, right at the tip here somewhere. It might be right here, right there, and right there. I don't know. Maybe further right at the very, very end. But you can see, that's where all the blood was. Now, let me try something, see if we can raise any more blood out of here. Because this side here has all these little blood pimples. Now, let's come down and see if we can find one that looks red enough that it might absorb. Wow, there's a good one right there. That looks promising. All right, let me come right down on that, and we're going to put a little blood on there, and then I'm going to wait a little while, and we'll come back and take a look and see if anything happens. Because it usually rehydrates very quickly. Let's see how good of a focus I can get on that. Well, either I get this one focused on that one or not that one. But I can keep jiggling it around. I'm going to put some water on there. And then we'll come back to it. Hold on. I can't find the water. Oh, got it. Okay, here we go. Here goes the water. And look at it turn red, red, red. I'm not expecting blood to come bubbling out, but I can tell you there's no question whatsoever. Right there is what issued that red blood. The little alveoli, blood vessels inside the alveoli. Now, I don't know if there would be catalase reaction in that or not. But I mean, you just saw it's a lung. I mean, here's what it looks like. Right there's a lung. There's alveoli all over it, and it had this blood coming out of it when it first came out of the ground. So, I mean, it's a lung. Now, I showed you the spurlock, so that's pretty convincing. And I could show you every different type of lung. I mean, I got them in every different type of stone. They would call this basalt, and this one here sandstone, and this one here quartz, and this one here whatever it is. And most of them are covered with basalt. With feldspar, because that is aluminum silicates. And why is it so important, aluminum silicates? Because they boil down from the phosphorus. The phospholipids, that's what the membranes are. Aluminum silicates are feldspars. Feldspars cover almost all the rocks there are, virtually almost all of them, because they all had membranes around them. So the feldspar, the phospholipids, the aluminum silicates actually, but they were phospholipids boiled down. It's one step down. Hold on. All right, this is hot water decay. Hot water decay will bring you from phosphorus down to aluminum and silicates, aluminum silicates. And the silicates were dense in the water from the salacious ooze when we almost got hit by Venus, because the salacious ooze is at the bottom of the ocean. They came up, and even Yale and all of them, they say it all happened because of dense silica in the oceans, and that's the only reason they preserve so well. I don't disagree with that at all. I have no problem with that whatsoever, because it's true. And it's because of the Great Flood, and it's because we almost got hit by Venus. And that is the thing that they have a very difficult time handling. Now, I'm going to take a look at this in a microscope. We'll see some of these, well, right up there, you see it? That's the alveoli. Let me turn this off. All of those little cavities were the alveoli. Now, this is where I put the water on. You can see it's a little bit reddish. But these are all the alveoli holes. Nobody came up there and chiseled little round spots on there. And I showed you the spurlock on it, and it has the shape of a lung, and it has blood coming out of it, so I'm going to go with lung.